Okay, so making the table was the focus of the last video. For this video, we're going to now assess whether or not there's a statistically significant effect or a statistically significant difference in the frequency between one versus the other. So we had just made a table here called e-cig table by year. If we want to see, and then when we ran it, when we did the, e-cig table by year, e-cig table by year. Oh. Well, we run our e-cig table by year. When we got our table here and we do it, what do we see? We see 412 and 93 here, 361 over 141. Your hypothesis might be that the frequency of recent e-cigarette use has increased significantly from 2014 versus 2018. So you could actually do a Chi-square test on that particular table. So this table, we called it e-cig table by year, and it runs our Chi-square test. And there you have it. The p-value is 0.003. If you haven't done the options Sci-Pen thing, you may see a different p-value. But here we can see that there is definitely a statistically significant difference somewhere in this table between the frequencies. Alright? Now, another way you might be able to do that, if you've all got, I might be able to do Chi-SquareTest and then the stuff that went into that table. So in this case, we made it e-cig 30 days by year, e-cig 30 day by year, and it might be able to run it that way, which it does. So you can do it without creating the table. If you're interested in seeing is there a difference in the frequency of e-cigarette use among those who had ever had any prior military service in this study, you could do that as well by doing e-cig 30 days, comma, military, and then it runs it. Now, here it says error in this because I typed in my formula wrong, right? You can see the mistake there. I should put Chi-SquareTest and then e-cig 30 days, comma, military, and then that goes ahead and runs it, and we see that there is no statistically significant effect. In fact, the p-value is very far from 0.05. It's really high. It's 0.896. So we would say that it's insufficient evidence to conclude that there's a significant effect or that there's a significant difference in the frequency of e-cigarette use among those who had versus those who had not served in the military. Alright, you could actually create a table, I'll just call it table 1 if you want to see this. Now there may be I have to put table in front of there. So table 1 equals that. And now if I want to see this, and you can see 25%, 30 out of 40 here, and that. I can replace it with proportions if you want to. So easy enough. Now there might be an additional layer that you want to add to this. For example, you may have a year that you want to look at as well. So we may do my table, 3. I'm just giving it a random name. And then we're going to do table, and then we're going to do e-cig 30 days, comma, military, comma, year. So we've got all of those. I can do my table 3, and you can see it's got them split up by year. So that's 2018 or 2014, and 2018 is below. You can also replace this or I could run a Chi-SquareTest on that. And you'll notice that the Chi-SquareTest doesn't necessarily work on this three-way table so easily. So we can do summary, and then my table 3 is what I called this thing, and now it did it. So easy fix. So here's the p-value, 0.00376. Now this particular Chi-SquareTest though is telling you that there's a difference between one of those several groups. I mean, there could be a difference by year, and so it's not as easy to tell you which part made the significant effect. So, but there is something significant going on, and then if you wanted to break it down closer, you'll need to do that to figure out where that significant effect is at. So you have this p-value of 0.003756. So whenever you do Chi-SquareTest on larger data sets, I don't say data sets, but larger tables where you've got multiple columns and rows that go beyond 2 by 2, if you get to like a 2 by 3 table or 2 by 4 table, any one of those particular differences is enough to cause a statistically significant effect. You don't know exactly which one caused that, so you would have to do further investigation if you needed to. So that's a little bit on how to do a an analysis by the three-way. But there's other tests that are out there that might be more important than the Chi-SquareTest. So in the next video we're going to talk about the Fisher exact test and its purpose. So we're going to stop this one here.